The sun has been burning for 4.6 billion years. And it still hasn't gone out. Amazing, right? Let me clarify something that many people still misunderstand. The sun is not a giant ball of fire burning fiercely. It doesn't burn wood. It's not plugged into electricity or powered by batteries. Yet it still shines brightly every day, as if it's never had the chance to shine before. So how does it burn so consistently for so long? You've probably heard that the sun is a giant fireball, right? But actually, it doesn't burn like wood or gas, as we often think. It's actually undergoing a process called nuclear fusion. Sounds like heavy nuclear physics, but don't worry. I'll explain it in the simplest way possible. The sun is a massive ball of gas, mostly hydrogen and helium, deep in its core. The temperature reaches about 15 million degrees Celsius. Yes, just 15 million degrees Celsius. Hot enough to force hydrogen atoms to smash together and fuse into helium. And every time this fusion happens, a tiny bit of mass is converted into energy, which is the light and heat that Earth receives every day. That's nuclear fusion, a natural power generator. No on-off switch needed, no battery charging and required. Most importantly, it runs steadily for billions of years without stopping. Hearing this, you might think, wow, it's used so much, it must be running out of fuel soon. Actually, not at all. Every second, the sun consumes about 600 million tons of hydrogen to produce energy. Sounds like it's burning through a lot, but according to scientists' calculations, it's only used up about half of the hydrogen in its core. In other words, if the sun were a giant gas tank, it still has enough fuel to keep cooking, lighting, and warming us for about another 5 billion years. So don't worry. You don't need to stress about running out of sunlight anytime soon. Just keep chilling, dry clothes, and sunbathe as usual. The sun is still working hard. So when will the sun go out? The short answer is, not today. And definitely not in the next few million years. But if you're patient and wait about 5 billion years, it'll happen. When the hydrogen in its core runs low, the sun will start to age. It won't produce energy as stably as before. At that point, the core will begin to collapse, but the outer shell will expand. And the result? The sun will turn into a red giant star, so massive it could swallow Mercury, Venus, and possibly even Earth. After that, in a final act of going out with a bang, its outer gas layers will be blown off into space, leaving behind a dense core called a white dwarf. No longer producing energy, the white dwarf will slowly cool, fade, and eventually disappear silently, like a candle that's burned out its wick. But for it to completely cool and vanish might take tens of billions of years, like a fire that's gone out, but still smolders for another 10 seasons. Sounds kind of sad, but actually, that's the normal life cycle of a star like the sun. And most importantly, the sun is still in its prime, the most vigorous stage, while we humans are probably still arguing about whether dipping bread in condensed milk is right or wrong. So rest assured, if there's ever an apocalypse because the sun goes out, that's a problem for billions of years from now. For now, we've got plenty of other things to worry about, like electricity bills, deadlines, reports, and what to eat for dinner tonight. Beef stir-fried noodles, or morning glory. Wait a sec. Why doesn't the sun just explode with all that nuclear fusion? The answer sounds simple, but it's actually incredibly intricate. It all comes down to a super tight balance between two forces battling it out constantly inside the sun. And this battle has been going on for over 4.6 billion years without a winner. Inside the sun's core, the temperature is extremely high, reaching 15 million degrees Celsius, causing hydrogen atoms to collide and fuse together. That process is called nuclear fusion. And every time it happens, a bit of mass is converted into energy, releasing light and heat that Earth receives every day. Sounds like a giant reactor, right? Exactly. But here's the catch. Nuclear fusion tends to push outward, creating pressure that wants to blow the sun apart from the inside. Meanwhile, gravity, the immense pulling force from the sun's massive mass, does the opposite, pulling all matter toward the core, trying to compress it tightly, like a wrestling match between two equally matched opponents. Thanks to this perfectly balanced struggle, the sun maintains its current shape. It doesn't collapse, explode, or deform. This state, in astrophysics, is called hydrostatic equilibrium. A term that sounds very peaceful, but is actually a breathless tug-of-war between two enormous forces. If it's off by even a tiny bit, it could go haywire by tens of miles. So what would happen if the sun suddenly went out? Sounds like science fiction, but let's imagine for a moment. Just to understand how important the sun is. First, for the first 8 minutes, no one would notice anything. Sunlight takes about 8 minutes and 20 seconds to reach Earth. So if the sun vanished instantly, everything would seem normal. For a few minutes, you'd still be sipping coffee, checking your phone. Cars would still be zooming along the roads, but then darkness would fall, no daylight, no moonlight, because there'd be no sun to reflect, no more sunrises or beautiful sunsets, just an endless night. And cold, very cold. Within a week, global average temperature could drop below minus 20 degrees Celsius. Then after a few weeks, it minus 70 degrees cold Celsius, enough to freeze the oceans from the surface down. Plants would be the first to go. Without light, there's no photosynthesis, no oxygen production. The food chain collapses. After plants come insects, then birds, animals, and humans. Without the sun's energy, there's no life as we know it. Some bacteria and microorganisms around hydrothermal vents at the ocean's depths might survive longer because they don't rely on sunlight and live off Earth's internal heat. But those are the last remnants of a once vibrant Earth. To put it bluntly, without the sun, Earth becomes a frozen, lifeless rock, drifting aimlessly in the Milky Way. So the next time you find the sunlight too bright and have to shield your eyes, remember that light, though a bit annoying, is keeping this entire planet alive. The sun isn't just a bright object in the sky, it's the backbone of life, and you're orbiting around it. Not figuratively, but literally. The sun is the master power generator for the entire ecosystem. Without the sun, Earth would no longer be a green planet, but a lifeless rock, cold and drifting in space. Sad and desolate, soulless and dark. And what's even amazing is that all this immense energy comes from smashing hydrogen together. No wood, no gas, no fuel, just physics, extreme temperatures, and time. The sun is the clearest proof that nature can create machines greater than any human invention. In short, the sun doesn't burn, it fuses. It's a massive natural nuclear reactor, operating stably thanks to the balance between the force of nuclear fusion and the gravity from its enormous mass. And thanks to that delicate balance, the sun has lasted so long, shining, warming, and nurturing life on our planet. You used to think the sun was a flying ball of fire, right? Don't worry, we thought so too. Now you know. It doesn't burn. It's undergoing intense nuclear fusion for 4.6 billion years and shows no signs of quitting. So if you think the sun is absolutely carrying Earth like a champ, give this video a like As a fiery shout out to the sun, subscribe to the Y channel to expand your mind a little every day, and turn on notifications because there are brilliant truths you don't want to miss. What mystery do you want us to unravel next? Comment below. Who knows, your question might become the next video in the series. For now, goodbye and see you again.